So in the previous video, we introduced permutation and combination. We specifically looked into permutation and we looked into the different types of permutation, such as the conditional permutation, permutation involving indistinguishable objects, and cyclic permutations, and we solved numerous of examples to explain the concept of permutation in that video. So I'll be leaving the link of that video in the description of this video so you can watch it for proper understanding. But in this video, we're going to be looking into combination particularly. So we said that in permutation, we are more interested in how objects are arranged following an orderly manner. But if you're interested in how objects are being selected without paying attention to order, you talk about combination. Yeah? So combination is simply the process of selecting objects without paying attention to the order of arrangement. So for instance, let's say we want to select arrow object. Okay, let's say we want to select arrow object from N. Then this is called combination, and it is symbolized as N combination arrow. Mathematically, it is given as N factorial all over N minus arrow factorial multiplied by arrow factorial. So this is the formula for combination. So if you pay attention, you recall that when we did permutation in the previous video, you recall that we said permutation, N permutation arrow is simply what? N factorial all over N minus arrow factorial. So you see that in the formula of combination, we have N factorial all over N minus arrow factorial, arrow factorial. So this means that combination can also be defined as what? N permutation arrow all over arrow factorial. All right, so let's solve some examples, that has to involve combination. All right, so let's say we're asked to select 3 objects from 5. Okay, so let's say we're asked to select 3 objects from 5. So whenever you hear the word select, it simply means combination. All right, so we have this to be 5 combination 3, and this is going to be equal to 5 combination 3. So 5 combination 3 is going to be equal to 5 factorial all over 5 minus 3 factorial. Okay, 3 factorial. So this is going to be equal to 5 factorial all over 5 minus 3 is 2 factorial times 3 factorial. So if you evaluate this, you have that 5 combination 3 is equal to 5 factorial is 5 times 4, so you can simply leave it as 3 factorial since you have 3 factorial at the denominator. So divide 2 factorial is 2 times 1 times 3 factorial. So here 3 factorial easily strikes 3 factorial. These two are out. So this is going to be equal to 5 times 4, which is 20, divided by 2 times 1 is 2, and that simply gives us what? 10. Okay, so you observe that N being the number to be selected from, and arrow being the number that is being selected, N is usually greater than arrow, yeah? So you have 5 being larger than 3. Okay, now let's solve a few examples to back up the concept. Now let's say we are given the question, in how many ways can 2 prefects be selected from a class of 15? So once again, N is always going to be the total number. So number of class, N is equal to 15. N is equal to 15. And then we have to select arrow is equal to 2 prefects from 15. So whenever you hear the word select, that simply means combination. In permutation, we are more interested in the order and arrangement. But in combination, we simply talk about selection without arrangement, yeah? So you have that 15 combination 2 is equal to, this is 15 factorial all over 15 minus 2 factorial multiplies 2 factorial. So you have 15 factorial all over 15 minus 2 there is 13 factorial times 2 factorial. So 15 combination 2 is going to be equal to 15 factorial is 15 times 14 times, so since you have 13 factorial at denominator, you can simply kill this multiplication at 13 factorial. Okay, all over 13 factorial times 2 factorial is 2 times 1. So 13 factorial actually cancels 13 factorial. So you're left with 15 times 14. And that simply gives us 210. So you have 210 all over 2. 210 divided by 2. This simply gives us 105. So which means, okay, you have 105 ways. So it means that 2 prefects can be selected from 15 students or in a class of 15 in 105 ways. Let's get more examples. Now let's consider this question. It says, find the number of ways a committee of 5 consisting of 3 males and 2 females can be formed from a social club consisting of 8 males and 7 females. So first, we find the number of ways of selecting 3 males from 8 males. Yeah, we find the number of ways of selecting 3 males from 8 males. So that is represented as what? Let's call that x1. So let x1 be the number of ways of selecting 3 males from 8 males. So that is represented as what? 8 combination 3. So this is 8 factorial all over 8 minus 3 factorial multiplied by 3 factorial. So you have this to be 8 factorial all over 8 minus 3. That is 5 factorial multiplies 3 factorial. So x1, which represents the number of ways in which 8 males or 3 males can be selected from 8 males, is given simply as 8 factorial is 8 by 7 by 6. So you can kill it at 5 factorial since we'll have 5 factorial at the denominator. So divide by 5 factorial multiplied by 3 factorial is 3 times 2 times 1. So from here 8 factorial cancels out. This cancels this. Okay, so we now have 8 times 7 times 6. That gives us 336. So we have 336. Okay, divide by 3 times 2 times 1 is 6. So this simply gives us 56 ways. So firstly, okay, the number of ways of arranging of selecting three males from 8 males is simply 56 ways. Then let's say x2 is the number of ways of selecting 2 females from 7 females. So you call that 7 combination 2. The number of ways of selecting 2 females from 7 females, that's 7 combination 2, which is 7 factorial all over 7 minus 2 factorial multiplies 2 factorial. 7 factorial is, okay, you have 7 factorial all over 7 minus 2 there is 5 factorial multiplied by 2 factorial. Okay, so 7 factorial is actually 7 times 6 times, let's kill it at 5 factorial since we have 5 factorial at the denominator, so they can easily cancel. So multiply by 2 factorial, which is 2 times 1. So 5 factorial here easily cancels this 5 factorial at the numerator. So we have x2 to be equal to, x2 is now going to be equal to 7 times 6. That gives us 42. So you have 42 divided by 42 divided by 2, and that is simply 21 ways. Okay, so this is the number of ways of selecting 2 females from 7 females. Now the question is asking us, in how many ways can a committee of 5 consisting of 3 males and 2 females can be selected from a social club consisting of 8 males and 7 females? All you need to do is multiply x1 and x2 together and you have it. So the number of ways, call the number of ways x. So we simply say x is the number of ways of doing that selection, and that is going to be equal to x1 multiplies x2. And x1 give us 56 ways of selecting 3 males from 8 males. So you have 56 multiplied by 21 ways of selecting 2 females from 7 females. So we simply find 56 multiplies by 21, 1176 ways. So you have 1176 ways. Okay. Alright, so I'll pause the video here, and in the next video we are going to be looking into different questions involving both permutation and combination. So we are going to be doing a mixed question. Alright, so to be a part of that video, of course, you know what to do. Smash the subscribe button, turn on your notification bell so you don't miss out on that video when it drops. In the meantime, do well to like this video, share to your friends, and comment nicely. I will see you in the next video. Thanks.